Hello sir, myself D. Kiran Sai Kumar. I am from EC department. In this assignment, I get a topic about principle and applications of UV visible spectroscopy. In this, first of all, we can discuss about introduction about UV visible spectroscopy, and then later we can discuss about principles of UV spectroscopy, followed by Beer-Lambert's law, and then about instrumentation, and then later spectra interpretation, followed by applications overview, and then case study, and we can see the advantages of this spectroscopy, and then later we can discuss about conclusion. Now first we can discuss about introduction. UV visible spectroscopy explores how substances interact with light in the UV and UV visible spectra. It analyzes the absorption of light by molecules to reveal electronic structure and concentrations. And now we discuss about principles of UV spectroscopy. In this principles of UV spectroscopy, we can have electromagnetic spectrum, electronic transitions. First we can discuss about electromagnetic spectrum. UV visible spectroscopy deals with light in the UV in 200 to 400 nanometers and visible 400 to 700 nanometers regions of the electromagnetic spectrum. Electronic transitions. Now we can discuss about electronic transitions. Molecules absorb light energy, promoting electrons from their ground state to higher energy states. Now we can discuss about Beer-Lambert's law. In Beer-Lambert's law, first we can see the definition. The law states that the absorbance of a substance at a particular wavelength is directly proportional to its concentration and the path length of the light travels through the solution. Now we can see the formula for Beer-Lambert's law. Mathematically it's expressed as A is equals to small a into small b into small c, where here small a represents absorbance and small b represents it is the path length of the sample, and small c is the concentration of the absorbing species. And now we can discuss about instrumentation. In instrumentation we can have light source and sample holder. First we can discuss about light source. It provides the light beam, covering the UV and visible ranges. Sources can include tungsten halogen lamps for visible light and deuterium lamps for UV light. Here we can see the picture which represents sources of light. And now we can see sample holder. Sample holder means it holds the sample solution or substance being analyzed. It's usually a cuvette made of glass, transparent to the UV vis wavelengths. And now we can see here UV visible spectroscopy diagram. Here first we can have light source, and then later we can have monochromator and sample, and then we can have detector. Here first the light source can went to this monochromator, and then later it reflects, and that reflector light can get into this sample solution and it is going to be detecting. In this way UV visible spectroscopy process is going to be happened. And now we can discuss about spectra interpretation. In this spectra interpretation we can have peak identification, quantitative analysis. Now in order we can discuss about these two. First we can discuss about peak identification. First of all, peak identification means spectra display peaks corresponding to wavelengths where the sample absorbs light. Peaks indicate electronic transitions specific to the compound. And now quantitative analysis means Here quantitative analysis means the height or area under a peak correlates with the concentration of the absorbing species. And now here we can see the diagram of this spectra interpretation. We can have 2 points, and here the 2 points is about the choice of reference signal, and the second point represents the choice of cross correlation method. This is the role of cross correlation in peak identification. And now we can discuss about the applications of this UV visible spectroscopy. In these applications we can have three types. This is environmental analysis, biochemistry, food and beverage industry. First we can discuss about environmental analysis. Environmental analysis means monitoring pollutants in water, air and soil, detecting and quantifying, assessing chemical composition in environmental samples. And now we can discuss about biochemistry. Biochemistry means analyzing biomolecules like proteins, DNA and enzymes. With this spectroscopy, we can analyze biomolecules like proteins, DNA and enzymes. And it is also used in food and beverage industry. That means analyzing compounds in food products like vitamins, dyes and additives, ensuring product quality and safety through quantitative analysis. With this spectroscopy, we can also use to find vitamins, dyes and additives, ensuring product quality. With this, we can also find the quality of the food and safety through quantitative analysis. These are the applications of UV visible spectroscopy. And now we can see case study. In case study, we can have two: objective and method. First, we can discuss about objective. Objective means quantify protein concentration using UV visible spectroscopy, and method means prepared protein samples in a buffer solution. In this diagram, we can also see the how process about prepared protein samples in a buffer solution. This is about the process, and now we can see the advantages of the spectroscopy. In advantages, we can have two: qualitative analysis and kinetic studies. First, we can discuss about qualitative analysis, identifying compounds based on their unique absorption spectra, aiding in compound characterization. And kinetic studies. Kinetic studies means monitoring chemical reactions by observing changes in absorption over time, providing insights into reaction rates and mechanisms. And in this spectroscopy, we can also see limitations. Limitations means we can have limited information, sensitivity, and complex matrices. In this, we can discuss about first limited information. Limited information means UV visible spectroscopy provides information mainly on electronic transitions, limiting its capability for detailed structural elucidation. And sensitivity means it might lack sensitivity for compounds with low absorption or at trace levels, requiring more sophisticated techniques for detection. And complex matrices means analysis of samples with multiple components can be challenging due to overlapping absorbance spectra. And finally, we can see conclusion. In conclusion, we can have versatility and identification and quantification. First, we can discuss about versatility. In versatility, UV visible spectroscopy serves diverse applications in pharmaceuticals, environmental analysis, biological research, and quality control across industries. This means UV visible spectroscopy is used to all these applications in like pharmaceuticals, environmental analysis, and biological research, followed by quality control across industries. In industries, we can also use this UV visible spectroscopy, and later we can have identification and quantification. In this, we can have it enables compound identification and concentration determination based on unique absorption spectra. Thanks, sir. Thank you for giving me this opportunity. Thank you, sir.